Hi everyone, welcome to section 8.4. Sorry this is taking long in getting to you, but we're close to the end, so let's be excited about that. So we're going to add and subtract rational expressions with unlike denominators. So first thing we need to do is to be able to find the LCD, okay? So to find the LCD of rational expressions, first thing is we need to factor each expression completely, and then we need to find the set of factors that combine them in such a way that every denominator will divide evenly into it, okay? So so the way that the book does it is to match them vertically and then bring down the columns and multiply the factors. I guess we could try that. Let's see here. Let's factor this. So this would be 8 over x minus 3x plus 1. Okay, and then this would be 3x over x plus 3 x plus 1. So your least common denominator. Okay, so it's very easy to see which ones are pairs. So you include the pairs, right? So these two, you represent, this one represents both of these. And then you have to account for these two. So it would be x plus 3, x minus 3, okay? And this would be something that both of these would divide into, so it's good. The way the book says to do it is, you have x plus 3, x plus 1 for one of the factors. And then the other one was x plus 1, x minus 3. But then it said to bring them down like this. And your LCD is x plus 3, x plus 1, x minus 3. I mean, that's fine too. But if you just think of it as, okay, when I see 2, I just need to represent it once. And then everything else that's new, you put that in there. Okay, so we just did that. Oh, no, rewrite as equivalent rational expressions with this denominator. So remember what this was. 8 was over x minus 3, x plus 1. And then 3x was over x plus 1, x plus 3. Then we say, okay, here's my LCD. I'm going to multiply top and bottom by what's missing. So I have an x minus 3, I have an x plus 1. So I'm missing from the first one an x plus 3. So I'm going to multiply top and bottom by x plus 3. So remember, when you multiply by a number over itself, it's equivalent to multiplying by 1. So this would be 8 over x plus 3. 8 times x plus 3 over, and then the LCD. And then the next one, what's missing, you have an x plus 1, you have an x plus 3, you're missing x minus 3. So then you would multiply top and bottom by x minus 3. So this would be 3x, x minus 3 over, and then the LCD, x plus 1, x plus 3, x minus 3. Now, do you need to multiply this out? You will if you have to add and subtract them, which we are going to be doing. So let's see here. To add and subtract rational expressions, we see if they have a common denominator. If yes, we rewrite. We go ahead and add and subtract. But if they don't have a common denominator, we need to figure out what that is, right? So 12 is 6 times 2, and 18 is 6 times 3. So they both have a common factor of 6, but then you need to include the 3 and the 2. Another way to think about it is, this would factor out into 2 and 3, 2 and 3. And then you would say, okay, these are my this is prime factorization. So your LCD, you have to, so this is in common, so that's a 2. What else? They have a 3 in common, that's a 3. This actually is your 6 from earlier in the beginning. Times, and then you have a 2, and then you have a 3 left. And that's it. So your LCD is going to be what? 24? No, just kidding. What is that? 8. No, this is 4 times 3, 12, 36. Which makes sense, because if I was to use the multiple method, what are the factors? The multiples of 18. The first one that meets is 36. Okay. All right. Okay, so then once you do that, we say, okay, what factor do we need to multiply in order to get to 12? Well, we need to multiply top and bottom by 3 times 3. That gives you 21 over 36. And then 5 over 18 times 2 is 10 over 36. And we're adding them, so then that becomes 31 over 36. Okay? So let's do that for here. So my LCD is going to be what? So 12x squared y, what's the factors of that? We have 3 times 2 times 2 times x squared times y, and 21xy squared is going to be 3 times 7 times x times y squared. So the LCD is going to be what? So we have the 3 in common, so 3. And then we have this x squared can be thought of as x times x, right? So we have an x in common, that's that. And we have one y in common, sure. So that's y times y, so these y's. But then we need to include every factor that hasn't been counted. So we need to include 2 squared, which is 4. So times 4 times 2 squared times 2 times 7. And then, of course, we have the x and the y times x times y. This is not like, obviously, if we were to simplify this out, so we have 3 times 4 is 12 times 7 is 84. Okay, so we have 84, and then we have x squared, y squared. Okay, so when you're finding the LCD and there's like repeated factors, it's easier just to get the highest exponent of each term, and there you go. Yeah, so now I know I have to combine these two so that I get 84x squared y squared on the bottom. Squared y squared. So what do I multiply top and bottom to get to 84x squared y squared? So then I need to multiply here by 7y. And that's going to give me 84x squared y squared on the bottom. And on the top, I'm going to get 35y. Here, to get to 84, I'm going to have to multiply top and bottom by 4 x. Okay, so that'll give me 16x here, and on the bottom I get that 84y. I'm adding them, so I would write this 16x plus 35y all over 84x squared y squared. Okay, we're going to do a few more. So when you have different denominators, the LCD is easy because it's just a product of the two different denominators, like that. So then here, we have to multiply top and bottom by x minus 2. Top and bottom by x minus 3 on this one. Okay, so the first one will be 3 times x minus 2 all over x minus 3, x minus 2. And then plus 2 times the quantity x minus 3 all over x minus 2, x times x minus 3. You know, a shortcut would have been just to write it all in one, x minus 3, x minus 2. And then you distribute the top, okay, and add them. So you have 3x minus 6 plus 2x minus 6. So then your total will be 5x minus 12 all over x minus 3, x minus 2. So there you go. Let's do a couple more. Okay, so what about if I have something like this? So firstly, it's better if you factor it, so it's very easy to see what we have. Okay, so we have 2a, and then on the bottom I can factor out a b. I get 2a plus b plus 3a, and then this is a difference of squares. So this is 2a plus b, 2a minus b. So then your LCD is going to be, so your LCD is 2a plus b. They both share that. And then what's left? 2a minus b, and then times b, okay? So then, okay, so what am I missing? We need to multiply top and bottom by what's missing. So, of course, our end goal will be this. 2a minus b times b. What's missing from the top? We're missing a factor of 2a minus b from the first term. So write that in. And you're going to get 2a times 2a minus b plus, and then what's missing here, that's just the factor of b. So multiply top and bottom by b, and you get 3ab. So let's distribute the first one. So we get 4a squared minus 2ab plus 3ab all over 2a plus b, 2a minus b times b. So then let's combine like terms. This negative 2ab plus 3ab just becomes a regular 1ab. So it's 4a squared plus 1ab all over 4a squared all over the LCD, 2a minus b. Now, if we factor out an a, would that give us anything on the top? It actually wouldn't. So you can leave it like that, or you can just factor it. It's a good habit to factor, the top, because sometimes you will get something that cancels out. Okay, in this case, nothing canceled out. So your final answer, a times 4a plus b all over the LCD, which is 2a plus b, 2a minus b times b. Okay, now don't be intimidated by the writing. Like some people go, oh my God, that's so much writing. It's not. I rewrote it a bunch of times. So just so that you can see line by line what happened. Oh, I think we just did that. Okay, so we also did this one. Okay, so let's try here. X over x minus 3 minus x minus 2 over x plus 3. So subtracting is the same as adding. So your LCD in this case is going to be x minus 3, x plus 3. Okay, so then on the first, you have x minus 3, x plus 3, x plus 3, because that's what's missing. And then minus x minus 2 over x plus 3, where we're going to multiply top and bottom by x minus 3 here. Eventually, you could get to a place where you just skip this intermediate step and you go to this part here, x minus 3, x plus 3, and then you just write down here your x squared plus 3x minus, and then let's multiply this out, right? You can do box method, or you can do FOIL, or what have you. X minus 2, x minus 3, x squared minus 3x minus 2x plus 6. That becomes x squared minus 5x plus 6. So then let's go through and combine x squared plus 3x minus x squared plus 5x minus 6. So what does that do? That cancels these out. We get x minus 3, x plus 3. So then final answer, 3x plus 5x is 8x today. So you get 8x minus 6 all over x plus 3, x minus 3. But if we want to be super exact, we can factor the top and just leave it in complete factored form. So you factor out a 2, you get 4x minus 3 all over x plus 3, x minus 3. Oh, I wrote x plus 3 twice here. Sorry. X minus 3. All right. Should we do another problem? Let's see. How about we do one like this? What if you have 5c plus 4 over c minus 2 minus 3 over 1? So in this case, your LCD is an easy one. It's just c minus 2. So we have 5c plus 4 over c minus 2 minus 3 times c minus 2 over c minus 2. Okay, so now we just get across the top 5c plus 4 minus 3. I'm distributing this negative 3. Okay, minus 3 plus 6 over c minus 2. And then 3c, sorry. There's a c right there. So then that would give you 2c plus 10 all over c minus 2, factoring 2 times the quantity c plus 5 all over c minus 2, and you're done, okay? Let's do another one that looks a bit more complicated here. Here we go. So we have here W plus 2, 3W over W plus 2 plus 2 over W plus 7 minus, and then this here, which we know factors out into conveniently W plus 2, W plus 7. So this is your LCD, okay? So can we take this step where I go, okay, fine, I'm just going to write the LCD down here, okay? That's the LCD. Now what's missing? So with the original problem, I needed W plus 7. So W plus 7 to top and bottom, okay? And that's going to be 3W times W plus 7. For the next one, what's missing? I have a W plus 7, but I'm missing a W plus 2. So multiply top and bottom by W plus 2. So that's going to give you plus 2 times W plus 2. I'm saying W plus 2. Okay, minus, and then this one already has everything. But since you're subtracting this entire thing, you have to distribute that negative, okay? So that would be, actually, I'm just going to go ahead and write it like that. 17W plus 4, and I'll distribute it on the next step. Okay, so now let's go ahead and use distributive property a bunch of times, yeah? And then we'll combine like terms. So 3W squared plus 21W plus 2W plus 4 minus 17W minus 4 all over W plus 2, W plus 7, okay? So let's see here. So on the top, you have 3W squared, 21 plus 2W, that's 23, minus 17W. So what is that? 6W, right? So this is plus 6W. Then you have 4 and minus 4. Oh, they cancel out. That's nice. And then you have a W plus 2W plus 7. But the LCD on the top here, I can factor out a 3W. So let's do that. So 3W, that leaves me with W plus 2 on the top over W plus 2, W plus 7. And for those of you that are like saying, oh my gosh, they're the same. Yes, they cancel out. Exactly. So that's why we factor everything, because sometimes you will have factors that cancel out. Okay, so that's it for this section. Good luck. Oh, sorry, let me go ahead and show that to you again. 3W over W plus 7. And then here you have your homework, section 8.4, 169 to 243, odd or every other odd. Good luck, happy studying, and I will see you in the next video.